Good morning, students. This is Math 1401 Statistics class. This is our first class in a way. You probably read the course outline. I'll mention a few things. If you go to the Blaze View page, you will see on the left-hand side, under Announcements, there is a link to my office hours. I will be here from 8:30 till 9:30, Mondays and Wednesdays. If you want to meet, if you want to meet me outside that window, you have to schedule an appointment via email. Okay. If you come during my office hours, I will be able to go over a few things that you don't understand, or if you have a question about the class, about the nature of the class, where things are. So today we're going to start chapter 5, which is probability. And after the lecture, you should be able to do the problems on MATLAB. If you can do something, email me, tell me specifically what class. Well, I'm teaching 3 classes, so always tell me what class you're talking about and the chapter number, section number, problem number, and ask me if I can help you with a problem. I will be able to upload a video or explain it in the next class. And I will tell you when you email me and say, can you do 5.1, number 5 from MATLAB? I will say, yes, I'm going to include it to my lecture in the next class and it will be available. One more thing. Let me go to the class, okay? Let me go to the class. So it's not our first class, but in a way it is. So give me 1 second, okay? All right. So I will record lectures on a regular basis. You'll do the problems that are available online. I'm going to go over it again, where things are, where the things will be. Okay. So by the things, I mean, your course outline, your exam, your text, and all that. If you watch this video, you will be able to follow me on a regular basis. All right. But you have to do the problems that will be assigned on MATLAB. I'll show you how you can access them. Just to let you know, I will do some problems during my lecture as I explain things. Those problems will be a fair game on the exam as well, so you do want to follow the lecture on a regular basis. Okay, so here we are. So hopefully you can see my screen. This is our class. So the office hours link is here. If you click it between 8:30 and 9:30 on Monday and Wednesday, I will be around. I may not be sitting right in front of the computer, but you can always say, hello, is anybody there? I'll be around, okay? So make sure you do that. I'll be able to answer your question directly. I won't be able to reteach you the class during office hours. That's not the purpose. This is an online class. This is an asynchronous class. Asynchronous means you're going to do your work. I'm going to upload my things. So if you can do something, you can email me and say, do that problem. So let me go over once again where the things are. The course outline is in this folder. Okay. Course outline right here, 1401. You want to see it. You probably won't see the instructor links, of course, for obvious reasons. You click this, scroll down to My Lab Statistics Pearson e-test text. If you click this, you'll have access to the whole book. Another link you want to be interested in is my statistics all assignments. There should be only one now, 5.1. Okay. It's due on July 27. Now it's due on July 27, but you want to do it on a regular basis. If you don't do it on a regular basis, I will give you the same problems on the exam. You won't be able to do them on the exam. Okay. You want to make sure you do the problems before the exam, ideally every day. One more thing. The exam dates are in the course outline. Okay. All right. So let's start our lesson today. So these little um, screenshots are taken from your book, sixth edition Sullivan statistics book. So the very first one, I don't know how well you can read, but I will not just read it to you, I will explain it, okay? A random process is basically process that you don't have any control over, all right? Now you can read it. You can read it in the text. It's from 5.1. It's in a box, the very first page. I'm not going to go to the book because I find this more convenient. Now, I'll give you some examples of a random process. For instance, rolling a die is an example of a random process. Tossing a coin is an example of a random process. You don't have any control, assuming it's a fair coin. You don't have any control over the outcome. If I have 10 students in a class, I write their names on 10 cards, put them inside a hat, and draw a name without looking. I will draw one of the 10 names I know, but I don't have any other control other than what I just outlined. So a random process is a process that you don't have any control over. What's a trial? A trial is you toss a coin once, that's your first trial. You toss a coin a second time, that's your second trial. Okay? So read the book, follow the video. When you read the book, of course, you'll read a little more. You won't just read the boxes, but it shouldn't be too bad. All right. Unfortunately, I have to go to the book, but that's okay. So the next one is the law of large numbers. Oh, let me go to the book for this one because I don't have, well, let me see how I can do it. Okay. So let me see if I can explain it to you as follows. What do we mean by the law of large numbers? Let me write it down here. And you want to understand this, okay? The law of large numbers. Okay. And there is a box in your book, but I'm not using the box because I didn't capture it right, but it won't make any difference, okay? You do want to understand this. This theme will survive throughout course. As long as we are teaching probability, we're going to use this idea. Now, let's say we are tossing a coin, okay? If I toss it twice, I might get head and head. So give me 1 second, guys. Okay, I'm doing a little bit of I'm making the numbers, the font a little bigger, okay? So you do want to genuinely understand this. I'm just going to write it like this. We're going to explain these symbols later. Okay, if you toss a coin twice, you might get head and head. That doesn't mean the coin is unfair or biased, all right? But you do know one thing, that there are two outcomes, okay? Head and tail. Half the time you're going to get head, half the time you're going to get tail. What we believe, and which is true in nature as well, if you toss a coin 200 times, you're going to get head about 100 times, tail about 100 times. So this works for large numbers. It doesn't work for small numbers. It's true. If you toss a coin 4 times, you might get head, tail, head, and head. That doesn't mean the probability of getting a tail is 1 out of 4. That doesn't mean the probability of getting a head is 3 out of 4. Okay. If you get a tail once and a head 3 times, doesn't mean the probabilities are off. It simply means probabilities work for large numbers. If you toss a coin 2,000 times, I can bet you will get head close to 1,000 times and tail close to 1,000 times. It won't be accurate. That's what law of large numbers, excuse me, that's what law of large numbers mean. I hope that makes sense, and I'm going to move on to the next one. Now, this will seem like a repetition to you because I've been giving you the same examples, but that's okay. Okay. So I'm gonna go over it a little bit, okay? I've given you these examples. So a probability experiment consists of rolling a single fair die. What's a probability experiment? A probability experiment is basically, I know it's the word experiment sounds very fancy, like you're doing a physics experiment, but it's really throwing a coin and observing what side shows up. Rolling a die is another example of a probability experiment. So we are being told a probability experiment consists of rolling a single fair die, identify the outcomes of the probability experiment, determine the sample space, define roll an even number. Okay, so I know the examples are here, but I will do them. Okay, so we are I'm going to define a few terms as we go along, guys. Here, we see a fancy word called sample space. Okay, what does that mean? What do we mean by sample space? Let me make it a little bigger for you guys. Okay, so when we roll a fair six-sided die, what could I possibly get? I could get a one sample space. So if I roll a fair six-sided die, the list of all possible outcomes is called the sample space. If I roll a fair six-sided die, I could get one or two, three, four, five, six. So that's my sample space. All right. And I'm going to give you one more example. Let's say if I toss a fair coin, my sample space will be head or tail. Okay, so I'm giving you two examples so that you understand the meaning of the word sample space. This word will be used a lot, all right? So if you roll a fair single six-sided die, your sample space will be one, two, three, four, five, six. If you roll a coin, your sample space will be head or tail. And we'll be drawing cards too. So when I get there, we'll give you examples in the context of playing cards. Okay, guys? All right. So we have this. Define the event, roll an even number. So okay, an event is basically a subset of the sample space. So sample space lists all the possible outcomes. An event could be any of those outcomes. It could be all of those outcomes. It could be none of those outcomes. So for instance, an event, I'm going to give you some examples of events, okay? An event would be rolling an even number. In that case, in that case, rolling an even number is an event, and in that case, it would be this. Got it? All right. What would be the event of rolling an odd number? Well, easy. It will be 1, 3, and 5. All right. You can say an event of rolling a number strictly greater than 4. How would I list all the outcomes that belong to that event? What is the event? I'm giving you another example. The event of rolling a number strictly greater than 4. It would be this, 5 and 6. Okay, we use curly brackets to list events and sample space. That's a custom. All right, that's plenty. So we have done A, B, C, D, and you can look at the box. It's basically saying what I'm saying, but you get the point, I hope. Okay, so guys, this will seem a little rough now. It'll make a little bit of sense once we do some of the problems. The probability that an event E, EE, that's how we write it. Probability E stands for probability E is your event, must be greater than or equal to 0 and less than or equal to 1. Okay, so any probability will be between 0 and 1. It includes 0 and 1. So if some event has a probability of 0, it will never happen. You're rolling a die, six-sided die, and you're expecting 7. Well, 7 will never happen. Okay. It's an impossible event. If you're rolling a die and you're finding out what's the likelihood of getting 1, 2, 3, or 4, or 5, or 6, well, you'll always get one of those numbers. So this will always happen. So the probability of any event will range between 0 and 1, including 0 and 1. That's why you have this underline here, okay? All right, so that's an important fact you have to understand and you have to remember. The sum of the probabilities of all outcomes must equal 1. This looks fancy, okay? Suppose your sample space S has these events E1, E2, E3, all the way up to En. So in our dice case, I know I'm going to use the dice example a lot. I write SS for sample space. They're using S. It really doesn't matter. It's all the same. Okay. So guys, let's make sure we understand this. I am rolling a regular, fair, six-sided die. My sample space is the list of all possible outcomes, and I have 1, 2, 3, 4, 5, 6. Now, what's the probability of getting 1? Well, there's 6 outcomes. There's only one, and the answer is 1/6. Probability of getting a 1. We sometimes write it like this. Probability of drawing a 1 is 1 out of 6. Okay, I'm not going to write it all. Probability of getting a 2 is 1/6. Probability of getting a 3 is 1/6. Probability of getting a 4 is 1/6. Probability of getting a 5 is 1/6. Probability of getting a 6 is 1/6. If you add 1/6 6 times, you're going to get 1. So this works for every single, it's a property of probability. It's a characteristic of probabilities. If you add the probabilities of all the possible outcomes that make the sample space, that sum will equal 1. Okay? I'll try to finish section 1. This is kind of our first day. So we'll see how things go. Yeah, we should be able to. Well, if we don't, we don't, okay? You'll still be able to do some of the problems from the book. Okay, so this is interesting, and you do want to understand it. So we find when we find probabilities, we really have two approaches. One is called empirical. You can see it here, empirical approach. The other one is called um, classical approach. Okay, so let's talk about empirical approach. So sometimes in the real world, we don't have a die. Okay, you don't have a die, you don't have a coin. What do you have? Let's say you're interested in finding out how many families have 3 kids. There is not a list. You can list the sample space. So what you do is you go find out, you interview, let's say you go from door to door and ask how many kids you guys have. People could say, we don't have any kids. We have 1 child, we have 2 children, we have 3 children, 4 or more. So you go now, so you ask, let's say you ask 20 families, okay? How many kids you have? Let's say 3 of them say, I have, uh, let's say 4 families. Let's say, let's write it down, okay? This is important. Let me write it down here. Suppose you ask 20 families this question. How many kids do you have? How many kids are in your family? Let's put that. Really doesn't matter too much. All right. So let's say out of 20, okay, 4 families say I have 3 kids. And that's what you're interested in, okay? Suppose 4 families say we have 3 kids. Now, this, what we're doing is called empirical probability because we don't have, it's not like a die that you can create a sample space. You can't. So what's the probability that a family will have 3 kids? You would say, well, that's easy. The answer is 3 out of 20. Now, you have to be careful, okay? We know asking 20 people will give you a very rough estimate of the true probability, but that's okay. I'm just trying to explain concept. An empirical approach is based on your experience, okay? Empirical means based on experience. Empirical approach, if you go ask 100 families how many kids you have, let's say 30 of them say they have 3 kids, your probability will be 30 over 100. All right, guys, let's move on. Okay, so one is empirical, one is classical. It's the classical approach. Okay, the classical approach is based on math, all right? Like we did with the probability of finding how many times would you get one if you roll a fair six-sided die. So it's based on math. It's based on theory, not experience. Okay. We will stick mostly to the classical approach. All right. Now you can read the box. I won't read it for you. So let's say I want you to find the probability of getting a number greater, strictly greater than 4 when you're rolling a die. Okay. The sample space is going to be the sample space rolling a die will be 1, 2, 3, 4, 5, 6. Okay. What's the probability of getting a number that's strictly greater than 4? And let's do it here and do it nicely. Probability of getting a number greater than 4. Okay. You can experiment. You can go ask how many people will get. You can roll about, you actually can roll a die and test it, but you probably won't. You're going to go with the classical method and you're going to say, okay, this is what you're talking about. We're talking about five and six only, right? So five is greater than four, six is greater than four. What's the probability of getting a number strictly greater than four? You will probably do something like this. You would say, well, that's easy. It's two over six, and we generally reduce it one over three. Done. All right. The good news is the videos are being uploaded. This video will be uploaded. You can pause it, stop it, and play it again. All right. So guys, so far we talked about rolling one fair six-sided die. If I just use the word die, I mean a die with six sides. There are dice with four sides, 20 sides, 12 sides. If we talk about them, we'll specifically mention. So what are they saying? Let's read it. A pair of fair dice is rolled. Fair die are die where each outcome is equally likely. Compute the probability of rolling a seven. So remember, you're rolling two six-sided dice. Compute the probability of rolling a snake eye. That is, compute the probability of rolling a two, one and one. Comment on likelihood of rolling seven versus likelihood of rolling a two. Once again, I have to construct the sample space very nicely, very carefully. We're actually wrapping up. I think we're doing a good job with regard to speed. So guys, the question is here. If I have to come back, I'll come back. But here is something you really want to understand. All right, what is this? Um, the first one is one. This one can be paired with this one from the second one, two from the second one, three from the second one, four, five, six. If you're rolling two dice now, it doesn't matter if you're rolling them simultaneously or you're rolling them one at a time. It really doesn't matter. Excuse me. So you can construct the sample space. The good news is your exams will be open book, so you can keep a copy of this picture and use it to solve problems that I'll give you. Now, in our question, this is the sample space. It looks a little different. Again, I'm going to go over it once again. One can be paired up with one, two, three, four, five, six. If you get two the first time around, that can be paired up with one, two, three, four, five, six. Three can be paired up with one, two, three, four, five, six. So this includes all the possible outcomes. So an outcome of a snake eye, I think that's the term they're using. Yeah, okay, that's this. They're all together 36 outcomes. One of them is your snake eye. So the answer is 1 out of 36. It's not very likely. Okay. Then they're saying compare that to the probability of rolling a seven. Look, you can get a seven in many ways. In many ways. So let me see. If I'm gonna write this, probability of getting a two. Just for convenience, I'm not gonna write snake eye and all that. I'm just going to say the probability of getting a two is 1/6. What's the probability of getting a seven? The probability of getting a seven is there are six outcomes that will get you a seven. It could be one and six, two and five, three and four and three, five and two, six and one. So that's going to be six out of 36 is equal to 1/6. All right. Now these are going to be a fair game on the exam. All right. So I will ask you, you're rolling two dice. What's the probability of getting a 7? What's the probability of getting a 6? What's the probability of getting a 12? I'm going to do one more. Let's say, what's the probability of getting a 12? Well, the probability of getting a 12 is also 1/6. You can get 12 only one way, right here, right here. All right. So here's a fair, it's a question like this will be a fair game on the exam. Now, you can redraw the sample space like I did, but you also want to make sure you have access to it because I will use this. You can write it on a piece of paper and keep it around when you're taking the exam so you don't have to redo the sample space. Of course, you can do screen capture and do all sorts of things. All right, guys. Now we're going to go over one more thing, and that kind of concludes this chapter for today. We'll conclude this chapter for today, and this one is a little hard. I'll warn you. Now, this came from book, an example in your book. Okay. So remember the three children example? Um, how many families have 3 kids? So of course you can go door to door and find out, and then find the um, empirical probability. But theoretically, what happens? The picture that you see in front of me, in front of you, is called a tree diagram. All right. So the first child could be a boy or a girl. Once you have a boy, it branches out twice again. The second child could be a boy or a girl. And whichever branch you choose, there is a third case, right? The third child could be a boy or a girl. So I'm not going to go over every single case. It's very tedious. Again, I'll give you one more example. Let's say your first child is a girl, and then second child could be either boy or girl. If you choose a girl, if you happen to have a girl, the second time around. The third child could be a boy or a girl. You'll list boy, girl. So now the tree has how many branches? One, two, three, four, five, six, seven, eight. So this is your sample space based on the tree diagram. Again, you could have a boy, boy, boy. I'm going to read it from top inside the rectangle. BBB, you could have 3 boys. BBG, BGB. Of course, the order matters. Boy first, then girl, boy. BGG, GBB, GBG, GGB, GGG. Now again, there's a lot going on. It's very easy when somebody explains it. It's a different thing to do it on your own. So I won't give you more than 3 kids. If I give you 2 kids, you're going to be stopping right here, right here. So it can't be that bad. All right. So again, this is your sample space. What kind of questions I can ask you on the exam? I can ask you something like this. I can say, find the classical probability that family with 3 kids will have 2 boys. What's the probability? Let's say you list all the families in the world that have 3 children. What's the probability that there will be 2 boys? Well, let's go find out. This one is a case where we have 2 boys, another 2 boys case right here, another 2 boys case. Sorry, you have to be careful. 2 boys. Done. Once again, you have collected data on families with 3 kids, and you want to find out how many of the families have 2 boys. Which you can ask them, right? But this one is the classical way of doing it. You are doing it in a theoretical way. This is also called theoretical probability. Theoretically, theoretically, out of all the families with 3 kids, it will be, what's the probability that they will have 2 boys? Let me get rid of this. The probability is going to be 3 out of 8. So we're stopping here. Okay, I am gonna show you this video will be uploaded and I'm gonna put the link here, right here somewhere. I haven't done it yet. I can do it in front of you while you, well, that's not gonna work actually. I won't be able to do it while I record because I'll have to get out of this recording system. It'll be here. Sorry, it's a different class. It will be here. Office hours link. It will be right above somewhere here. Okay. Once again, you should be able to do the problems from 5.1 now. I, I went over all the important facts. If you go to My Statistics, All Statistics, you should be able to do some of the problems. All right, guys, I'll see you Monday.